Hello guys, this is Jiten Jain and this is our 11th signal and system lecture. In last lecture, we have discussed about trigonometric Fourier series problems, exponential Fourier series problems, how to convert exponential Fourier series to trigonometric Fourier series coefficients, how to convert trigonometric Fourier series coefficient into exponential Fourier series coefficient. And we have also discussed about Gibbs phenomena, Dirichlet condition, properties of Fourier series, and in this lecture we will discuss few problems on Fourier series and Parsevals power theorem and concept of Fourier transform, why we need Fourier transform and how to derive Fourier transform from Fourier series. So let's start with problem of Fourier series. One problem is a periodic signal has the Fourier series representation Cn equal to minus n to the power minus mod n. Without finding x of t, find the Fourier series representation dn and omega naught of y of t. Okay. So y of t is given in terms of x of t, means y of t equal to x of 3t. We have to find y of t's Fourier series coefficient without finding x of t. One method is from Cn we find x of t, then using time scaling we find y of t, then again we find the Fourier series coefficient of y of t. That method is lengthy and we have to avoid that method. That's why what we do, we have given Cn of x of t. Using time scaling property we can find Fourier series coefficient of x of 3t also. So in time scaling, Fourier series coefficient remains same as we discussed in last lecture. Only what changes? Fundamental frequency changes, time period changes. So okay, so omega naught becomes 3 omega naught and dn will be same as Cn. Okay. Next is y of t equal to d by dt x of t. So dn will be equal to j omega naught and Cn. Okay, as we know the difference according to differentiation property. Okay, here omega naught is pi. It is given in question. Okay, it is given in question here. Omega naught is pi. So put omega naught equal to pi, you will find dn is equal to this. So next is y of t equal to x of t minus 1. So here time shifting property will be useful. Tn equal to e to the power minus j omega naught and t naught is 1 Cn. Put omega naught pi, you will find dn like this. Okay. Now next question is y of t equal to real part of x of t. We have to find real part of x of t. Okay. Each composition of real part plus j into imaginary part. So you take conjugate of that signal, you will find like this. Then to find real part, add them, you will find real part like this and imaginary part like this. So you have to find Fourier series coefficient of this na. So using linearity property you can find Fourier series coefficient. So 1 by c x of t Fourier series coefficient is Cn and x conjugate t as c minus n conjugate. Okay, yeah, remember na, x of t conjugates Fourier series coefficient is c minus n conjugate. Okay, next question is y of t equal to cos 4 pi t x of t. First write cos in terms of exponential terms, then as we know that in one domain exponential is complex exponential is multiplied, then in another domain the independent variable will be shifted, means here in time domain exponential term is multiplied, that's why in frequency domain frequency will be shifted. So here m is 4, that's why n minus, here Cn minus 4. Okay, you remember in time shifting same sign is applicable, but in frequency shifting opposite sign, means here plus 4 so we take minus, here minus 4 we take here plus 4, that's why. Okay, next problem is Parsevals power theorem. The total average power in any periodic signal is equal to the sum of the squared amplitude of each harmonic. Okay, how you find total average power? 1 by t integration 0 to t mod x t square dt. According to this theorem, this total power is equal to summation n equal to minus infinite to plus infinite mod cn square, means sum of squared amplitude of each harmonic. Okay, this theorem is applicable where we can not find power in time domain, we can find using Fourier series frequency domain also. Like here, find the power up to second harmonic for periodic signal shown in figure. We have to find power up to only second harmonic. Okay, we cannot find we cannot apply that overall power formula, total power formula. So what we do, if you want to apply that frequency domain formula like mod cn square, so first you have to find cn and c naught. How you will find cn c naught? You can find directly c naught, okay, but you can find directly, or you can find first trigonometric Fourier series coefficient, then you find cn. So c a amplitude here 10, a naught, how you will find a naught? A naught is overall area divided by fundamental period. So area is 10 divided by 2. So a naught is equal to 5. An will be 0 because this consists hidden odd symmetry. That's why an will be 0, but DC term will be non-zero because symmetry is hidden, and Bn will be non-zero. Bn you will find like this. Okay. So C naught will be equal to A naught. Cn equal to An minus JBn by 2. Okay. So you will find like this for odd n. Okay. For even it will be 0. Power required up to second harmonic. So take only limit n equal to minus 2 to plus 2 mod cn square. You will find up to second harmonic power is 0.45 watt, but if you calculate total power using time domain formula, you will find 0.5 watt. So you see that near about all power is lies in up to second harmonic. So okay, so what we can conclude here, maximum energy or power of any signal is always lies in the low frequency region. Okay. So next problem is the Fourier series coefficient of a periodic signal xt is expressed as like this, and Fourier series coefficient are given here, and c minus 2, c minus 1, c naught, c1, c2, and cn is 0 for mod n greater than 2. So which of the following is true? 3 statements are given here. 4. We have to, any one is correct. So what is correct? We have to find. First statement is x of t has finite energy because only finitely many coefficients are non-zero. It is wrong. That Parsevals theorem is applicable for power only in Fourier series for periodic signals. Okay, that power theorem means mod summation n equal to minus infinite plus infinite mod cn square is equal to total average power, not energy, because here Fourier series coefficients are given, means signal is definitely periodic, and for each periodic signal has infinite energy, but this statement says that energy is finite, means it is wrong. Second statement is x of t has 0 average value. Okay, I have written the same reason here also. A is wrong, y is wrong. Okay, and second statement is x of t has 0 average value because it is periodic. It is wrong. Average value is denoted by c naught, which is j2, which is non-zero. Second statement is also wrong. Third is the imaginary part of x of t is constant, and fourth is the real part of x of t is even. Let's check. X of t equal to xr of t plus j x of I of t. I told you that each signal can be each signal is can be represented in terms of sum of real part and imaginary part. So if you find Cn, if you use Cn formula, same previous formula, what you will find? You will find put here x of t, this. Now put n equal to 0. So C naught will be equal to, this term will be 1, and as we know C naught is 0 plus J2, which is given in question. Now you see that real part is 0, means integration of this is 0. Integration of any term is 0 means that term is also 0, means real part is 0, and in question real part is even given, which is wrong. So fourth option is wrong, so only third is remains, which is third is left, that definitely it will be right. Why? Integration of any term is constant, means it is independent of t, which will be only possible when imaginary part will be constant. If xi of t is constant, it will be outside, and here 1 is left, so integration of 1 is t, so t by 2 minus 2 t by 2, so t cancel, so you get that constant equal to 2. So imaginary part of x of t is constant, so third statement is right. So okay, next problem is topic is system with periodic input. So LTI system, for LTI system x of t is e to power j omega t, means input is e to power j omega t, complex exponential. So output will be y of t equal to e to the power j omega t into h of omega. Okay, only means e to power j omega t is eigen function, is called eigen function. Eigen function is one function which if we apply at input we will get same form in output, means we will get same form, only the amplitude will be changed and the phase will be changed. Okay, amplitude and phase will be changed, and that will be depend on h of omega. We put here whatever frequency will be here at input, we will put at h of omega at that frequency, we will calculate it. How you will prove it? You can prove it, it is very simple. Okay, y of t is given. Okay, y of t formula, as we know that for any LTI system output equal to minus infinite to plus infinite integration x of t minus tau h of tau d tau, using convolution formula. Put here input x of t as x of t minus tau, you will get like this. Then e to power j omega t take outside, which is independent of tau. Now you will, it is in the form of the Fourier transform. Okay, we will discuss it is next topic. So e to power j omega t h of omega y of t. Okay, so one problem is related to that periodic input. Find the output voltage of the system shown in figure if the input voltage is this. We have to find y of t and x of t, input voltage is given. First of all we find h of omega. Okay, it is also periodic, na? Complex exponential, cos, sine, all are periodic, all are eigen function. You can apply that this formula, you can apply this formula instead of this, cos or sine will be there. So how you will find for transfer function h of omega? So here y of t is nothing but, suppose current I is flowing here, so y of t is the I into r, so r is 1, so y of t equal to I. Okay, y of t is equal to I, so instead of I we can write y of t. So here apply a KVL, so you will get minus x of t plus L di by dt plus Ri. Instead of I you write y of t and put L r value, you will get, now apply Fourier transform, you will get j omega y omega plus y omega equal to x of omega. Actually it is periodic, that's why we cannot apply a Fourier transform. Actually we should apply Fourier series. But although you will find h of omega like this, if you apply Fourier transform also, you will find h of omega like this. If you apply Fourier series also, you will get like this, 1 upon 1 plus j omega. Okay, now put instead of omega and omega naught, you can put here. Okay, now we have given input as 4 cos 2t. As you know that output is equal to input into that h of omega. So instead of omega you have to put here, omega is 2 na, cos omega t, omega is 2, put here 2, omega equal to 2, and find magnitude as well as phase, and magnitude will be multiplied here and phase will be added in this theta terms. Okay, so if you find magnitude, here I solved in different manner. I told you the direct method. I have solved in different manner. First I converted cos into terms of exponential, then you can do that also, but I told you the direct method. What you have to first, you take magnitude means mod and phase, then put omega equal to 2, and the whatever magnitude will be, that will be multiplied here, and phase will be added in 2t. Okay, okay, next topic is Fourier transform. Next topic is Fourier transform. We will see a little bit about Fourier transform, means definition only. Fourier transform. What is Fourier transform? Why we need this? So transformation is the process in which one domain is converted to another domain, such that signal analysis become easy. Why we transform any signal? To make analysis easier. Okay, sometimes we cannot analyze any signal in time domain, then we transform it into frequency domain. Okay, so for any non-periodic signal, as non-periodic means time period becomes infinity, t tends to infinity, implies omega naught tends to 0. The discrete spectrum of Fourier series. Okay, the discrete spectrum of Fourier, if it means if a signal becomes aperiodic, then the discrete spectrum, Fourier series is a discrete spectrum as we know, then the discrete spectrum of Fourier series is converted to continuous spectrum in Fourier transform. Why? Because for aperiodic signal, non-periodic signal, t becomes infinity, that's why omega naught becomes 0. Omega naught becomes 0 means all discrete samples in spectrums are become at closer point, na? That's why the spectrum becomes continuous in Fourier transform. So Fourier transform is nothing but extension of Fourier series. So Fourier transform is extension of Fourier series to periodic signal, to non-periodic signal. Okay, I already told you that Fourier series is applicable to only periodic signal, and Fourier transform is applicable to non-periodic signal. X of t equal to e to power minus t u of t, and u of t is given. So here t becomes infinity, na? That's why both signals are non-periodic. Okay, so if you draw, suppose this above signal has, okay, this signal has Fourier spectrum, Fourier series spectrum like this. Suppose, okay, so some signal has Fourier series spectrum like this. Now here, if signal becomes non-periodic, means t tends to infinity, then omega naught tends to 0, then n omega naught tends to omega. Why? Omega naught tends to 0 means previously spectrum was like this, now omega naught tends to 0 means omega naught, this spectrum, this sample will be very closer to previous sample, means all samples will become closer like this. Now spectrum will be like continuous, means now n omega naught will become omega. Okay, here omega value was n omega naught, na? Here 1 omega naught, 2 omega naught, 3 omega naught. Now it all terms can be become omega. Now we have to put only omega's value here. Okay, so from how we will derive formula for Fourier transform? From Fourier series formula we know that x of t equal to minus infinite plus infinite cn e to power j omega naught nt. Cn equal to this formula we know. If t tends to infinity, take t into left side and take limit, you will find like this. And if you take limit t tends to infinity, omega naught into n becomes omega, and this term will be x of omega. Okay, So x of omega equal to integration minus infinite to plus infinite x of t to power minus j omega t dt. Okay, this is called Fourier transform of x of t. Inverse Fourier transform formula you can derive it. It's very simple. X of t equal to 1 by 2 pi integration minus infinite plus infinite x of omega e to power j omega t d omega. It is in omega terms. If you take in f term, the 2 pi term will be neglect. 2 pi will not come here. Integration minus infinite plus infinite x of e to power j 2 pi f t dm. Okay. So this is the Fourier transform. Okay. So the problems on Fourier transform we'll see in next lecture. And please, if you like this lecture, please subscribe for next lecture. If you have any suggestion related to this video, please share with me, and if you have any doubt, please write into the comment box so then I can help you. Okay, thank you.